Welcome back to our channel. Up to now, we have learned to differentiate single terms, constants, sums, and differences. But what if we have a function that is a product of two other functions? Today, we will learn the product rule which handles exactly this situation. What does this product rule state? If you have two functions multiplied together, say f of x and g of x, the derivative is the derivative of the first term times the second plus the first term times the derivative of the second. Notice the order. Derivative of the first multiplied by the second term, then you add the first term multiplied by the derivative of the second term. So in order to perform the product rule, we have been able to come down with 6 steps in order to follow for any product. What does this step say? First step, or step 1, identify your two functions. We always need to identify our f of x and our g of x in order then to apply the product rule. The second rule states differentiate f of x, that is f prime of x. The third rule states differentiate g of x, that is g prime of x. Fourth rule, multiply f prime by g and f by g prime. The fifth rule, add the two products. And the sixth rule, you simplify if simplification is possible. In order to put into practice all these different steps we have learned, we are going to tackle an example, which is as shown below. It's an example on a polynomial. This example states differentiate y equal to x squared times 3x plus 4. So we're going to use the same procedures we mentioned above. What does our first procedure state? Identify f of x and g of x. So first of all, what is our f of x? We will say let f of x be equal to x squared, and let g of x be equal to 3x plus 4. So in this case, we have been able to divide our function into two different terms, that is f of x and g of x. So we can then say that then y is equal to the product of these our two terms. Now that we have written y as the product of two different functions, we can then apply the product rule. Moving on to our second step. What does our second step tell us to do? Differentiate f of x. So let's start with our first function, f of x. The derivative with respect to x of f of x is equal to the derivative with respect to x of x squared. And what does this give us? It gives us 2x, 2 minus 1, which is equal to 2x from our product, our power rule. Moving on to our third steps, it tells us to find the derivative or to differentiate g of x. The derivative with respect to x of g of x is equal to the derivative with respect to x of 3x plus 4. And what does this give us? Following our sum rule, is the same thing as the derivative with respect to x of 3x plus the derivative with respect to x of 4. Now, on this first term, following our constant multiplier rule, is the same thing as 3 times the derivative with respect to x of x plus the derivative with respect to x of 4. Now we can then apply the power rule on this term, which gives us 3 times 1x to the power 1 minus 1 plus, now this is the derivative of a constant, and following our constant rule, the derivative of every constant gives us 0, so plus 0. This then reduces to 3x to the power 0, which gives us 3. So we now have our derivative of our first term f of x, which is f prime, and g prime, which is the derivative of our second function. Now we move on to our fourth rule. Our fourth rule tells us to multiply f prime by g and f by g prime. So that is what we are going to do. F prime times g is equal to What is our f prime? Our f prime is 2x. And what is our g? Our g is 3x plus 4. This gives us 2x into 3x plus 4, which gives us 6x squared plus 8x. Now our fourth still tells us also to multiply f by g. So what is our f? Our f is x squared. F times g prime is x squared times what is our g prime? 3. And this gives us 3x squared. Now moving on to our fifth term, our fifth step tells us to add the two results, that is f prime g and g prime f. So our fifth term tells us f prime times g plus f times g prime, and this gives us 6x squared plus 8x, which is our f prime times g, plus our g times f prime, our f times g prime, which is 3x squared. And from this addition, we have two like terms. We have 6x squared and 3x squared, which are both like terms, so we can add them together, which gives us 9x squared plus 8x. What can we then conclude from this? Our next step, simplify if possible. We have already performed a simplification, which was simplifying our 6x squared and our 3x squared. So what can we then conclude from this solution? Our derivative with respect to x of our function y, which was equal to the derivative with respect to x of x squared, 3x plus 4, and this gives us the answer 9x squared plus 8x. So that is our result. So in order to understand or to put into practice these different methods we have listed and above, and we have applied on this first example, we are going to tackle a second example, which will be more of a practical example. So what does this example state? We'll first start with practical example 1, or practice example 1. Let's say practice question 1, which is on fractional and negative powers. This question is as follows: differentiate x cubed into 1 divided by root of x. And this function can still be written as x cubed into x to the negative half. So following the same methods which we listed above, what was our first step? Our first step was to identify our two functions, that is f of x and g of x. So first of all, we will let f of x be equal to x cubed, and let g of x be equal to 1 on root x, which is same as x to the negative half. What did our next step ask us to do? If we go back to the steps, next step tells us to differentiate f of x. Our third step, to differentiate g of x. So that is what we are going to do. Let's start with f of x. The derivative with respect to x of f of x, which is same as the derivative with respect to x of x cubed, is equal to 3, that is following our power rule, x to the power 2 minus 1, 3 minus 1, which gives us 3x to the power 2. Moving on to our next term, the derivative with respect to x of g of x is the same thing as the derivative with respect to x of x to the power negative half. Still following our power rule, this is the same thing as negative half x to the power negative half minus 1, which gives us negative half x to the power negative 3 on 2. Now what does our fourth step ask us to do? Our fourth step tells us to multiply f prime by g and f by g prime. So that is what we are going to do. F prime times g is same as, what is f prime? 3x squared. 3x squared times, what is our g? Our g is x to the power negative half times x to the power negative half plus, well, this is our f prime times g. We can simplify that by 3x squared plus minus half, which gives us 3x to the 3 on 2. Now our footstep, our footstep tells us to multiply g prime by f, which is the same thing as f by g prime, and this gives us, what is our f? Our f is x cubed. Now what is our g prime? Half negative half x to the negative 3 on 2, which gives us negative half x to the 3 plus minus 3 on 2. Negative half x to the 3 minus 3 on 2, which is the same thing as, we can simplify this as 6 on 2, which is the same thing as 3 minus 3 on 2, which gives us negative half x to the, from here we can then directly subtract their numerators. Since the denominators are common, we have 3 on 2. Now following this, we move on to our fifth step, which tells us to add the different terms, that is f prime times g and g prime times f. So we have f prime g plus f g prime. This gives us 3x to the 3 on 2 plus minus half x to the 3 on 2, which gives us, from here we notice that these terms are like terms, right? Moving directly on to our sixth step, which tells us to simplify this term, we notice that we have two terms here and both terms are like terms. Why are they like terms? Because the part in x is the same, that is 3x to the 3 on 2 minus half x to the 3 on 2. So we can then factorize out x to the 3 on 2, which gives us 3 minus half. Using the same method above, we can simplify this as 6 on 2 minus half. Since both denominators are the same, we can then directly subtract the numerators, giving us 5 on 2 x to the 3 on 2. From here, we can then conclude, therefore, the differential with respect to x of f times g, which is x cubed times 1 on the root of x cubed times 1 on the root of x, gives us 5 on 2 times x to the 3 on 2. Another way for us to verify this answer is, if we look directly at our question here, we could directly simplify our initial question and use power rule. That is, x cubed times 1 on root of x is the same thing as x cubed times x to the negative half, which is the same thing as x to the 3 plus negative half, which is the same thing as x to the 6 on 2 minus half, which gives us x to the 5 on 2. Now applying directly our differentiation or our derivative on x to the 5 on 2, this gives us 5 on 2 x to the 5 on 2 minus 1, 5 on 2 x to the 5 on 2 minus 2 on 2, 5 on 2, x to the 3 on 2, and it gives us the same answers. What does that tell us? That tells us that simplifying the initial question might have simplified the solution, but still we did it using the product rule in order to emphasize the understanding of the method which we were moving through algebra, which is the product rule. So moving on to our third practice question, in order to solidify or to understand perfectly this concept, what does our third rule state? Let's write down the rule. Let's write our third question, sorry, not our third rule, our third question. Practice in theory can be written as differentiate y equal to x times, let's take a function, square root of 1 plus x. Now let's take square root of x cube times x to the negative 4. So this question is much more simpler than our second practice question, but you guys can still attempt it in order to ensure that you have understood the method of product rule perfectly. So following our first step, it tells us first of all to identify the two different terms. We can identify directly from here our f of x and our g of x. Second step asks us to differentiate our f of x. F prime of x is the same thing as f prime of x is the same thing as 3x squared. G prime of x is the same thing as negative 4x to the minus 4 minus 1, negative 4x to the negative 5. Moving on to our fourth step, which tells us to calculate f prime times g, which gives us 3x squared times negative 4x to the negative 5. Simplifying this gives us negative 4 times 3, which gives us negative 12, times x to the power 2 plus minus 5, which gives us negative 12x to the minus 3. Now g prime f, which is equal to f times g prime, is the same thing as negative 4 okay, sorry, there was a mistake here. F prime times g, there's no negative 4 here. It is, I took instead g prime of x instead of g of x, times our g is x to the power negative 4, which gives us 3x squared times negative 4 plus negative 4, which gives us 3x to the negative 2. So moving on to our next question, next part, which is g prime of g prime times f. Our g prime is negative 4x to the negative 5, and our f is x cubed. This gives us negative 4 times x to the negative 5 plus 3, negative 4x to the negative 2. Now what is our next question? Next part asks us to add these different terms, that is f prime g plus f g prime, which gives us 3x negative 2 plus negative 4x negative 2. The final part or the final step tells us to simplify this question, which we can do directly, identifying that both terms in our final solution are like them. So we have 3 minus 4, which gives us minus x minus 2. So what can we then conclude? Therefore, the differential with respect to x of our question or of the function x cubed times x to the negative 4, x cubed times x to the negative 4 is equal to negative x to the negative 2. So thank you for this video. See you on our next video. Bye.